The nucleus of an atom is made up of two types of particles, protons and neutrons. Protons are positively charged while neutrons carry no charge. This gives the nucleus a net positive charge. Electrons are negatively charged particles that experience a force of attraction from the positively charged nucleus. This force of attraction results in the electron orbiting the nucleus. For simplicity, we will assume that this explanation is true, although as we will later see, this is not exactly accurate. The electrons are at different energy levels or shells. Each shell or energy level has a number assigned to it called the principal quantum number. It is shown by n. For the first energy level, n equals 1. The first shell or energy level can hold up to 2 electrons. Similarly, for the second energy level, n equals 2, and for the third energy level, n equals 3, and so on. The second energy level can hold up to 8 electrons. Now wait a moment. If you're wondering how I calculated the maximum number of electrons in each shell, well, here's your answer. That's a very simple formula of 2n squared, where n is the principal quantum number. Here's an example so you can understand this better. For the second shell, n equals 2, and putting that in the equation gives us 8. Similarly, for the third shell, putting n equals 3 gives me the answer as 18. That means that the third shell can hold up to 18 electrons. Now take a moment to calculate how many electrons the fourth shell can have. If you answered 32, you're correct. These electrons are contained in subshells within the shells. There are 4 subshells, named S, B, D, and F. Each shell has different number of subshells. For instance, the first shell has only one subshell, that is the S subshell. The second shell has 2 subshells, S and B. Likewise, the third shell has 3 subshells, S, B, and D. And if you're guessing that the fourth shell has 4 subshells, you're correct. The fourth shell and every other shell after the fourth shell have 4 subshells, S, B, D, and F. Now going into a little bit more detail, these subshells have something called orbitals. Orbitals are 3-dimensional regions of space where there's the highest probability of finding an electron. Remember the model of the atom we saw before? That isn't actually accurate. Electrons don't really have that fixed rigid orbit that we saw before. In fact, electrons can be found anywhere. But orbitals make it simpler for us to understand where there's the highest probability to find them. We'll see more on that later, but first let's understand subshells and the number of orbitals they have. So far, we have learned that shells have subshells and subshells have orbitals. Each orbital can hold up to 2 electrons in opposite spin. The S subshell has only one orbital, which is spherical in shape. Since it has only one orbital, it means that it can only hold a maximum of 2 electrons. That explains why the first shell can only have a maximum of 2 electrons. One S orbital will be smaller than the 2s orbital. You'll be able to understand this clearer later in this video. The P subshell is dumbbell shaped and has 3 orbitals, which means it can hold up to 6 electrons. The orbital oriented along the x-axis is the px orbital. Likewise, there are py and pz orbitals. The D subshell has a shape that looks something like 2 dumbbells being joined together, so we call them a double dumbbell shaped. There are 5 orbitals, which may look pretty weird to you, but let's take a look anyway. There's the xy orbital, the xz orbital, the yz orbital, the x square y square orbital, and an unusual dz square orbital. Did you understand how these orbitals are oriented? If you understood that, that's excellent. Moving on, the F subshell has a much weirder shape that looks somewhat like this. The F subshell has 7 orbitals, but it's quite difficult to give one name to the shape of all of them because they are very different from each other. So for now, we can say that there is no definite shape for the F subshell. Since there are 7 types of F orbitals, we can say that the F subshell can hold up to 14 electrons. Well, here's an example to summarize everything that we have learned so far. Taking the carbon atom as an example, we know that its electronic configuration is 1s2, 2s2, and 2p2. A simpler representation of the carbon atom would look somewhat like this. But in reality, if you can imagine this in 3 dimensions, it would be more similar to this. Notice how the electrons are contained within the orbitals. That's how they surround the nucleus.